Okay, we will go through some important points in the class 12 max chapter 7 integrals. To understand this chapter, you go through the reference videos mentioned in this description of this video. So you should know basic differentiation to understand this integration. These are the various methods of integration: integration by substitution, integration by partial fraction, integration by parts, trigonometric functions, then properties of the integration. So first you should read the theory part of this and then try some examples. Okay, example, integration by substitution. What is the theory behind it? Then try to solve some examples so that you will understand the theory. So the derivative means is a differentiation. Example, x square. The derivative of x square is 2x. That is, we are differentiating x square to get with respect to x to get 2x. Now if you integrate 2x, then you will get x square. Okay, that is antiderivative of 2x is x square. So these two are the reverse process. F of x after differentiation you get f dash of x. F dash of x after integration we will get f of x. Okay, antiderivative means we are doing integration, derivative means we are doing differentiation. So from antiderivative to derivative is called integration. So there are two types, indefinite and definite. So indefinite without any limits, definite will have a limit. So integration, inverse process of the differentiation. Integration is inverse process of differentiation. Instead of differentiating a function, we are given a derivative. That is, after differentiating, you are given a derivative then of a function and asked to find the primitive. So if you take sin x, if you differentiate sin x, you will get cos x. So if you integrate cos x, you will get a sin x. So this is primitive, this is a derivative. Primitive, derivative. Similarly, the other examples. So sin x is an antiderivative of cos x. Okay. So here we are using the constant. You go through the first reference video, the importance of the constant. Okay. Doing integration, result of integration, we are adding a constant, arbitrary constant. So you can have a function with the same derivative but with a different constant, differ by the constant. I will show you the examples in the book. Okay, functions with the same derivative differ by constant. So this is how you read. Okay, integral f of x dx, integral of f with respect to x. Okay, this is how you read this. F of x in the this within integral is a integrand. This is integrand. X variable of integration. Integrate, find the integral. Okay, and integral of a function f. Okay, integration, the process of finding the integral. Constant of integration, any real number is considered as a constant function. Those are all definitions. So these are the some derivatives and antiderivatives. Okay, so you need not memorize, but if you differentiate x power n, you will get so if you differentiate x power n plus 1 divided by n plus 1, you will get x power n. n is not equal to -1. If you put n equal to -1, this will become 0. Anything by 0 is a infinity. Okay, so that should not come. That is why it's not equal to -1. And you put -1, that will become infinite. So sin x, cos x, these things you can go through it. In parentheses model, do not mention the interval over which the various functions are defined. However, in any specific problem, one has to keep in mind this interval. Geometrical interpretation of the indefinite interval. See, now here you see x square plus c is an arbitrary constant. By varying c, we will get different curves, but we obtained y equal to x square, a parabola with vertex origin. The curve x square plus 1. Okay, we are just varying the constant, but the curve will be same. Okay, family of integrals by assigning different value of the different members of the family. Okay, see here, all these derivatives will be same. Only thing with the constant differ in the constant. All are parabola only, but they are having different constant. Parabolic with different constant. Have the same derivative. Okay. Properties of the indefinite integral. The process of differential integration are the inverse of each other in the sense of the following results. Okay, you can go through it. So c is the arbitrary constant. This is the proof. Two indefinite integral with the same derivative lead to the same family of the curves. Okay, example f the parabola. C is any real number. That is the proof. For any real number k f of x equal to k outside, we are taking out of the, this is the constant, out of the integration that we are doing. Method of inspection. So we will see what is the method of inspection. Basically, you should know the differentiation. Okay, write the antiderivative of the following in the method of inspection. Cos x means you know the sin x, cos x are related. Differentiate sin x, you will get a cos x. Okay, here 2x has come. So how they are doing? dy dx of sin x 2 cos 2x. Okay, then cos 2x you are taking this side, then 1 by 2. Okay, then after that antiderivative of cos 2x is, so basically you should know the differentiation. Okay, differentiation of which function will give cos 2x. So sin 2x will give the cos x, then accordingly you modify this. Here 2x is coming. Similarly, for this function, which function after differentiation gives this? Okay, this after differentiation will give this. This is method of inspection. For log x is 1 by x. So you are using the various properties mentioned here. Okay, property, you can go through what is those properties. From now onwards, we will use only one constant of integration. Okay, only one constant instead of using two constants. So both these integrals we use only one constant here. This after integration, this after integration, we are using only one constant. This is the exponential and the log x. log x exponential. So you try this also. F of 0 equal to 3. When the variable integration is denoted by the variable other than x, the integral formula are modified accordingly. Okay, here we are using y, so dy. Differentiation and integration comparison. So you can go through this. In this exercise, if you have time, you try most of it, but at least try these things. The various method of integration: integration by substitution, integration by partial fraction, integration by parts. So integration by substitution, this is the theory. Then based on theory, there is some examples. Okay, given integral f of dx can be transformed into the another of independent variables by substituting x equal to g of t. Okay. So now if you solve one example, then you will understand what is this theory. Okay. This is the condition. Usually we make a substitution for a function whose derivative also occur in the integrand. Okay. Whose derivative, that is a differentiation of that, also occurs in the integration. Okay, here in this example you see sin mx. So in the mx, when you do differentiation, you will get m. So that is the derivative. So that also occurs here. So that when you make substitution, so usually we make substitution for a function whose derivative also occurs in the integrand. Okay. So now we are using substituting for the mx. T equal to mx. Okay. M dx equal to dt. Okay. This is how you make substitution whose derivative also occurs in the integrand. Okay. So you will understand this if you go through these solved examples. Okay. Here. So dx equal to dt by m. Okay, dt by here, then 1 by m we are taking out. So we'll get one constant. Similarly here, the derivative of is 2x. Okay. Then you place this. So here one more substitution we are making. Okay, first substitution, then one more substitution. So here use of trigonometric functions. Tan x dx equal to this. So you can try these things. These are solved things. Okay, again you try some of the problems here yourself. So integration using trigonometric identities. Okay, some known identities. Okay, cos square x, this formula cos 2x equal to cos square x minus 1. So you should know the trigonometric identities for this. These are the identities equal to this. exercise. Again you try some of the things. Integral of some particular function, special functions, okay, dx by x square minus a square equal to 1 by 2x minus plus c. See, x square minus a square, okay, x minus a by x plus a. Similarly here a square minus x square, you see here difference is there, a plus x by a minus x. Here dx is there, so here x minus a by x plus a, but if you interchange a and x, you see plus it is coming here. This is the result, okay. By practice only you will be able to remember these things. How they are substituting, you see. Okay, you can try out this. They are given the solution, but you can try out yourself. First you go through how they solved, then you try yourself. So integration by partial fractions. Recall that a rational function is defined the ratio of the two polynomials p of x by q of x. Polynomial q of x is not equal to 0. That is the rational function. So what is proper and improper? If the degree of p of x is less than the degree of q of x, then it is a proper rational function. P of x degree should be less than the q of x. Then proper, otherwise it is improper. So if it is improper, how to convert into a proper? So improper to proper, you add additional one more polynomial. T of x is a polynomial, okay. Then this becomes a proper one. So these are some the partial fraction rules. How to write this in terms of a divided by x minus a. Okay. So you will understand those rules if you solve this problem, like dx by x plus 1 into x plus 2. Proper is a proper because this degree is less than this degree. Proper rational function, therefore using that formula, one of the formula. So here equating the coefficient of x and constant terms, you see ax here, bx, okay, coefficient of x is 0 here, so a plus b equal to 0, coefficient of x. 2a plus b equal to 1, that is the constant. 2a plus b, that is the constant, this one constant. Then after solving you will get this. So you see how they are equating this coefficient and the constant. Coefficient of x, a plus b, ax plus bx, x you take a plus b equal to 0 this side. So symbol this means to indicate the statement is an identity. Symbol equal to statement is an equation. So this is not a proper function. So the here degree should be less than this, but here it's equal, not a proper. So you divide this by this. So how to divide the polynomial? You should read your 11th or other chapters. How to divide polynomials. So here if you see equating minus 3a minus 2b equal to minus 5. So you are cancelling negative on both sides. So you will get 3a plus 2b. Okay. substitutes. So here in the below examples we are using both integration by substitution as well as partial fraction. Okay, so here in this example where we are doing substitution, then we are using the partial fraction. Here in the same problem we are using both the rules, substitution as well as partial fraction. This is a proper, okay, here this degree will be more because here x cube will come x square, so this is a proper rational function. So integration by parts. So here is like a product rule of differentiation, u v dash plus v u dash, the product rule. Here we are using the same rule for integration. Okay, d by dx of uv equal to u dash, this is dv by dx, v du by dx. Integrating on both sides, finally you will get this is the result. Okay, so this is the rule. The integral of product of two functions equal to first function into integral of the second function minus integral of the differential coefficient of the first function. Okay, you will understand this when you are doing example. Okay, now we are going to apply this here. So x cos x, okay, product one first function x, second function cos x. So here first function into integral of the second function, first function x, integral of the second function, that is second function is cos x, minus integral of differential coefficient of the first function, differential coefficient of the first function, that is a differential coefficient, then into integral of the second function, integral of the second one cos x dx. Okay, this is how first function second function in this rule. Shows that above is reduced to the comparatively more complicated, therefore proper choice of the first and second function is significant. Okay, when you are choosing the first and second function, should proper choice. So these are the conditions, you cannot use these rules. Here we cannot use that rule. Again here also, here log x, first function is not there, so they are multiplying it by 1. So first function log x, second function is 1. So here first function, second function, to use the product rule we are multiplying it by 1. So they are showing different techniques how you should use that rule. This chapter is a big chapter, so you should spend some time to understand these various rules, integration rules. So some more types based on the techniques of integration by parts. So you are applying product rule again here, the above product rule, then the result is this. Similarly you apply the rule for other things. Try sum of it. Definite integral. So here in difference between the definite integral, here we are going to use some limits, like here AB. We are going to integrate within those limits only. So that is the definite integral. Indefinite, no limit. So this will be used when you find area of the curve within this interval a to b. This is how you represent the interval between this interval f of x dx is the area bounded by the curve y equal to fx. This is the area from x equal to a to x equal to b, area under the curve. See, rectangle ABLC is less than the radii of the region. This. Okay, so if this you can see from here. This rectangle ABLC is less than ABDC, this region, that is less than ABDMA. Okay. So here this is a rectangle and this is one region and this is above that. So that is what they have mentioned. Basically they are making infinite number of strips here. Infinite number of strips. So h is nothing but the width. H tends to 0. Tends to 0 means this one. Between this tends to 0 means the infinite number of rectangles they are making. So you will get the better accuracy. N tends to infinity. Okay, number of strips. So h is tends to 0, number of strips tends to infinity. Then that infinite strips you will get the better accuracy. So now we are going to apply a definite integral within 0 to 2. So we are going to use that limit b minus a. B is 2a, a is 0, that is 2. So h equal to 2 by n. Okay, n is tends to infinity. 2 b minus a, limit n tend to 1 by n. Okay, 2 by n, because this is h, that step is 2 by n. 2 by n, 4 by n, 6 by n it will come. So here also the limit b minus a is 2 by n. So this is the limit. Sorry, that is the step. Limit is 0 to 2. You find the step b minus a divided by n. Area function. Area function, definite integral. These are the theorems of this integral. F of x continuous function on a closed interval a b. Let a of x is the area of function, then a dash of x equal to, basically derivative of this is this a dash of x. These are the steps calculating limit a to b f of x dx. These are the first, second fundamental theorem mentioned above. How to use those theorem here. Partial fraction. So this is method of by substitution. See, basically the indefinite integral, definite integral, substitution method is same. Only thing here we are going to use the limits. Okay, the limits, indefinite integration limit was not that, but here we will be applying limits here. So we are going to use substitution rule, then apply these limits, -1 to +1. So here we are doing substitution, same thing as above indefinite, but finally we are going to apply the limits here. In indefinite we don't apply limits. Okay, here in terms of this tan and 0 to 1 will how they are changing into 0 to 5 by 4. You see this how they are changing the limits. So here this is the important properties. Okay, so here A to B, you are changing B to A with a negative sign. This is one of the property. Similarly, see here A to B, there is a positive sign, but B to A it will become negative. So these are as properties you should you will get familiar as only if you try some problems. Okay, these are a proof of those properties. So using that properties, how they are evaluating this. Okay, so they have mentioned which property they are using, so you can go through those properties. See in this example which property they are using. Similarly for the other examples also. So these are the miscellaneous examples, so you can try out these things also. So you go through the reference videos attached in this description, so you will understand the various integration rules. After going through the video, you try out yourself. Summary, you read this. These are some standard integration functions. Integration by partial fractions, integration by substitution, some special functions, by parts, special types of integrals, area functions. Okay.